Read this problem carefully and think yourself. Here we have to use this third kinematic equation to solve this. A particle moves along circle of radius r with constant tangential acceleration. This is the particle actually we can imagine it is moving along a circle of radius r and its acceleration is tangential. What does it mean? It means that the magnitude of velocity v changes. Actually, initial velocity of that particle during its circular motion is quite less, or you may say zero, because the particle is starting its motion. Therefore, its initial velocity can be considered to be u equal to 0. After some revolutions, this is the first revolution, this is the second revolution, velocity of the particle is v. Therefore, after two revolution, velocity becomes v. What he asks then, its tangential acceleration is. They are going to ask you the tangential acceleration a, what is its, and these are four options in front of you. So to solve this problem, as I said earlier, you have to use kinematical equation, and especially the third kinematical equation, v square is equal to u square plus twice a into s. Here v is the velocity after two revolution, u is the initial velocity. As the particle is starting its motion, therefore its initial velocity we are going to consider 0. A is the tangential acceleration and s is the distance covered by the body, or you may say the particle, in two revolution. So let me put those values. V is already given, final velocity of that particle is u. This is given to you. Okay. The velocity final is v square as it is, no change. U square is the initial velocity. As it is starting its motion, we have already considered that its initial velocity u equal to 0. Therefore, let me put the value of u as 0. 0 square becomes simply 0. Plus 2 into a is tangential acceleration. This is because of change in velocity, magnitude. Now let's talk about the distance. Yes, in one revolution, the particle completes one circle, means one circumference. The distance covered in one revolution is one circle, means one circumference, means it is equal to twice pi r. Therefore, the distance covered in one revolution is s is equal to twice pi r. But as the particle completes two revolution, therefore the distance covered in one revolution is twice pi r. In second revolution again twice pi r. Therefore the total distance covered in two revolution is twice pi r into 2. So this is what you have to put the value of s as twice pi r into 2. Somewhere here s is equal to twice pi r into 2. Now let me summarize it. V square is equal to 0 plus 2 into a into twice pi r into 2. So what will the value of a now? Just let me put the value, let me calculate the value of a here. Transferring all these terms to twice pi r and 2, our expression for a will be like this. v square upon this 2, this twice pi r, again that 2, it will become a. So what we get? We get a is equal to v square upon this 2 into 2 4 into 2 means 8, again this pi and r, 8 pi r. So the final expression or the final value of tangential acceleration is v square upon 8 pi r, and which is option A is correct. Thank you. The same problem can be solved by using the third kinematical equation in rotation motion. Try this.